Bismillahirrahmanirrahim, dear students. Assalamu alaikum. Hope you and your family in the best of health. Lecture for grade 9, subject chemistry, chapter number 6, think tank, and chapter number 7, introduction. Lecture number 12, and I am Mrs. Saira Jamal. Think tank question number 1. A 10 grams of solid solute is placed in 100 grams of water at 20 degrees centigrade and all of it dissolves. In 100 grams of water, we will add 10 grams of solid solute and temperature is 20 degree centigrade. If in the same solution we add 4 grams more and temperature is same 20 degrees centigrade, that 4 grams will also dissolve in it. This is the question. 10 grams we dissolve in 100 grams of water. Temperature is 20 degrees centigrade, room temperature. And if we add 4 grams more in the same solution or in the same 100 gram water which have 10 grams of solute in it, temperature is same 20 degrees centigrade. So part A is the first solution saturated, unsaturated or supersaturated. The first solution, it was unsaturated because it can dissolve 4 grams more in it. If it was unsaturated, then the 4 gram will settle down at the bottom, but the 4 gram also dissolved in that solution means that the solution was unsaturated. B part, is it possible to tell from this information that the final solution is unsaturated or saturated? Yes, it is possible because a solution which can dissolve more of the solute at a given temperature, it is called unsaturated solution. So as this solution dissolved 4 gram more in it, so this is an identification that the solution was unsaturated solution. That is why it dissolved 4 grams more in it. Question number 2, what should you do to change a saturated solution to an unsaturated solution? There are two ways. First way is add more solvent in it or add water in it. Definitely the saturated one will convert it into unsaturated. And second way is increase temperature, heat the solution. So if you will heat it, what will happen? The undissolved salt will dissolve in it and then intent solution will convert it into unsaturated solution. Second part or B part, an unsaturated solution to a saturated solution. It's understood that to convert unsaturated into saturated, we have to add more solute in it. And we will go on adding more solute in it until the extras settle down at the bottom. And temperature is given, means temperature is constant. Question number 3, knowing the molarity of a solution is more meaningful than knowing whether a solution is dilute or concentrated. Explain. If we have in a lab a solution and nothing is mentioned on it, and a second solution on which molarity is mentioned that it is 0.1 molar solution, and in a practical we need 0.1 molar solution. So which solution you will take? The one on which is it is mentioned that it is dilute, or the one on which the exact concentration is mentioned. So it's understood that we will take the one on which the exact concentration is mentioned on, because we know it is 0.1 molar and we will directly use it. If the other which is on which only mention that it is dilute, we will first find out that what is the concentration of that solution and then we will use it. So this is good, or this is more meaningful to mention the concentration on it or molarity mentioned on it. So knowing the molarity is more meaningful because by knowing it, you can not only know if it is dilute or concentrated, but also the exact concentration or also the exact molarity you will know. Question number 5, design an experiment to prepare 10% mass by volume solution of copper sulfate pentahydrate. It is also called Nila Tota. And we have to prepare 10% mass by volume concentration. So for this, we have to take This is copper sulfate pentahydrate or Nila Tota. Take 10 grams from this bottle, then dissolve it in some water, and then transfer that solution into 100 ml volumetric flask and add water in it till mark. This is the mark. So add water in it till mark. This will be our desired 100 ml 10% mass by volume copper sulfate solution. Okay. Which solution? So if we add 10 gram copper sulfate in sufficient water means till mark, and the volumetric flask is 100 centimeter cube, then the resultant solution will be 10% mass by volume. Okay. How much centimeter cube? 100 centimeter cube solution. Percent means 100 centimeter cube solution. Question number 6, which solution is more dilute? 50 centimeter cube of 0.2 molar sodium hydroxide or 100 centimeter cube of 0.1 molar sodium hydroxide. So for this we will find out the number of moles for both solutions. Both solutions are of sodium hydroxide. So we will use molarity formula and then we will find out the number of moles. So first we will write molarity formula and putting the values after converting the volume from centimeter cube into decimeter cube, and then by putting it into the formula we will get number of moles 0.01 moles. Okay, this is in for the first case where molarity is 0.2 and volume is 50. Second case when molarity is 0.1 and volume is 100 centimeter cube. Again we will convert 100 centimeter cube into decimeter cube. Then by putting into the molarity formula we will get the number of moles 0.01 moles for 100 centimeter cube solution and 0.01 mole for the 50 centimeter cube solution. For both the solution, the number of moles are same. So same number of moles of solution means that the concentration of both solutions are same. Question number 7 is same like the previous one, but in this case we have two different solutes. One is sodium hydroxide and another one is hydrochloric acid. So we will not follow the previous method. In this case, you will find out the number mass of HCl and mass of sodium hydroxide. In previous example, question number 6, both the solution were of sodium hydroxide, so that's why we found the number of moles. But in this case the two solutes are different. One solute is hydrochloric acid and another solute is sodium hydroxide. So we will find out the masses and then we will see the mass of which solute is greater. So again we will use the same formula, molarity formula. Mass of solute over molar mass into 1000 divided by volume of solution in centimeter cube. We will put the values and find out, taking out the mass, we will have 0.365 grams for HCl, and the same we will do for sodium hydroxide. The mass is 0.4 grams. So the mass of sodium hydroxide is greater than hydrochloric acid. So as mass of sodium hydroxide is greater than hydrochloric acid, so sodium hydroxide is solution of sodium hydroxide is more concentrated than hydrochloric acid. Question number 8, benzene is a common organic solvent. Its use is now restricted because it is carcinogenic. It causes cancer. So its use is restricted. Like if we are using it in labs, so we are using it in very small concentration, like 0.32 milligrams per decimeter cube of air. It is recommended, or it is present. We have to find out the molarity. So first convert milligrams into gram by dividing it on 1000. Then convert the mass, so the volume which is in decimeter cube into centimeter cube. Find out the molar mass, write the molarity formula by putting on the values. We will get the molarity 4 into 10 raised to power 6 molar, or you can also write it in this form. Both are correct. Question number 9. A patient in a hospital is often administered an intravenous drip Patient mostly are given a drip in veins. It is intravenous, mean in vein, and this drip contain sodium chloride solution and glucose solution. How much sodium chloride is in it? 0.85% mass by volume sodium chloride and 5% mass by volume of glucose. So 0.85% mean 0.85 grams in 100 grams and 5% mean 5 grams in 100 gram or 100 ml. So as it is mass by volume, so 0.85 grams in 100 ml of solution and 5 gram in 200 ml of solution. For both these solutions, we have to find out molarity separately. Okay. First, we will find out in case 1 for sodium chloride, and in case 2, we will find out for glucose. So for sodium chloride, mass of solute, I told you 0.85% mean 0.85 grams. Okay, and volume is understood 100. So volume is 100 centimeter cube. We need molar mass, so 23 is for sodium and 35.5 is for chlorine by adding 58.5 grams per mole, and then we will put it into the formula, and molarity is 0.145 molar. Now we will find out for glucose. 5% means 5 grams and percent 100 centimeter cube, same. And molar mass of glucose, formula of glucose C6H12O6. So molar mass is 180 grams per mole, and by putting it into the formula, we will get the answer. Question number, the answer is missing here, so you find out the answer by putting value. Mass I told you is 5 gram, molar mass 5 divided by 180, 1000, and volume is 100. Okay, 1000 by 100 and 5 by 180. Solve it out, it will give you the answer. Question number 10. 100 centimeter cube of sodium hydroxide was heated until dryness and 1.5 gram residue left behind. What was the molarity of the solution? Again, molarity. Mass is 1.5 gram and volume is 100 centimeter cube. Molarity of sodium hydroxide we know is 40, and by putting all these values into the formula, 1.5 grams by molar mass of sodium hydroxide into 1000, volume in centimeter cube is 100. Answer is 0.375 molar. Question number 11. Design an experiment to distinguish between a saturated and supersaturated solution. Saturated solution, you know, which cannot dissolve more solute in it and it will settle down at the bottom. And supersaturated solution is a solution, saturated solution when we heat it, the undissolved solute will dissolve in it, and then after adding more solute in it, we will reach at a point when no more solute will dissolve, and that solution is called supersaturated solution. So experiment is take 100 gram water in a beaker, add a teaspoon of sugar in it, stir it, and then sugar will dissolve. Repeat the process by adding more and more sugar in it until the extra settle down at the bottom. Now heat that solution and start on adding again the solute or sugar in it until we reach until you reach the state when the extra salt settle down at the bottom. This solution is called super saturated solution. Okay, so this is the experiment through which you can prepare a super saturated solution, and you can differentiate between the two solutions. Hope you understand this think tank. Coming towards the image, in this image you can see we have a saturated solution, and after heating, the saturated solution can dissolve all the solute in it, and by adding more solute in it, we will see it is converted into super saturated solution. You can see the amount of solute in it lesser than greater, and you can see the amount of solute increases from saturated into saturated solution. Hope you understand the chapter number 6. Dear student, now we are going to start next chapter, very important chapter, very conceptual chapter, and it is chapter number 7. Name is electrochemistry. So let's start it by the name of Allah. Bismillahir Rahmanir Rahim. Electrochemistry is the branch of chemistry that deals with the relation between electrical and chemical reactions. Electrical and chemical reactions. In the image, you can see that a chemical reaction can produce electric current. So it means that chemical energy can be converted into electrical energy, or electrical energy can be converted into chemical energy. So what is the relationship between these two? Inshallah, we will learn or we will study in this chapter. It involves oxidation and reduction reaction, which are also called redox reaction. These type of reactions are called redox reaction because in these reaction oxidation and reduction takes place simultaneously. So what is oxidation and reduction? Let's start it. But before starting, the major concept which we will study in this chapter are oxidation and reduction, oxidation states and rules for assigning oxidation state, oxidizing and reducing agents, oxidation and reduction reaction, electrochemical cells, electrochemical industries, corrosion and its prevention. All these topics, inshallah, we will study in this chapter. First topic is oxidation and reduction. What is oxidation? Gain of oxygen is called oxidation. Loss of hydrogen is called oxidation. Loss of electrons are called oxidation. And increase in oxidation number of atoms of element or of element is called oxidation. Reduction is the opposite of oxidation. Gain of oxygen, so reduction is loss of oxygen. Loss of hydrogen is oxidation, so gain of hydrogen is reduction. Loss of electrons is oxidation, so gain of electrons is reduction. Increasing oxidation number is oxidation, so decrease in oxidation number is reduction. So both processes are opposite of each other. We can explain oxidation and reduction by two ways. First, let us explain oxidation and reduction in terms of loss or gain of hydrogen and oxygen. Okay, the first two terms, loss of hydrogen and gain of oxygen in case of oxidation, and loss of oxygen and gain of hydrogen in case of reduction. First, we will explain it. Okay. What is oxidation? Oxidation is defined as gain of oxygen and loss of hydrogen atom by an element, and the reduction is loss of oxygen and gain of hydrogen atom by an element. Let us see some examples to understand these processes. First example is steel mill. In steel mills, iron ores. Ores, you know, is the impure form of the mineral, or impure form of iron in this case is ore. Okay, this is called iron ore. The formula is ferric oxide. It is also called hematite, which is the impure form of iron. And we need pure form of iron. We can get the pure form of iron from this impure iron by using a special type of furnace called blast furnace. You can see the image of blast furnace. This is a real blast furnace, and this is just the image of blast furnace. In this blast furnace, the impure iron or the ferric oxide is heated and then reacted with the carbon monoxide, which then converted into the pure iron. And the temperature of this furnace is until 1700 degrees centigrade. So this is called blast furnace. So in blast furnace, what happened? This ferric oxide or oxide of iron are converted into pure metal, pure iron, and commercially by on a large scale, you can see on industrial scale, by the reaction with coke carbon in the blast furnace. Carbon react with oxygen first and form carbon monoxide, and then the carbon first react carbon monoxide, and then this carbon monoxide react with iron oxide, or also called ferric oxide, or also called ore of iron, and will give pure iron and carbon dioxide gas is liberated. Which substance in this reaction loses oxygen? So ferric oxide, it loses oxygen because in this case you can see three oxygens are present with iron, and in this case no oxygen, iron is alone, or it is in the metallic form or in the free form. So iron loses oxygen atom. So loss of oxygen is called reduction. Yes, so iron is reduced by losing oxygen atom, and that oxygen is gained by carbon. Carbon in this case you can see has one oxygen, and in the product it has two oxygen atoms. So carbon gain oxygen, so gain of oxygen is called oxidation. Carbon is oxidized, or carbon monoxide is oxidized by gaining oxygen atom, and ferric oxide is reduced by losing oxygen atoms. Okay, and I told you oxidation is defined as gain of oxygen atoms or loss of hydrogen atoms by an element. Got it? So which substance is oxidized? Yes, carbon monoxide is oxidized, or carbon in carbon monoxide is oxidized. Which substance is reduced? Yes, ferric oxide. Ferric oxide. Iron in ferric oxide is reduced by losing oxygen atom, and carbon in carbon monoxide is oxidized by gaining oxygen atom. This was the first example. Coming toward the second example, acetylene. The formula is C2H2. It is commercially on large scale is used for cutting and welding. You can see this flame. This is called oxyacetylene flame, and this flame is very high temperature. This temperature even it can melt the metals, and then those metals can be welded, or they can be cut. You can cut it or you can weld it, like repair it. Okay, so this special type of flame is called oxyacetylene flame is used for this purpose. When acetylene burns, it produces a very hot flame known as oxyacetylene flame, and following reaction takes place when it burns. At burning, the reaction takes place. If you can see formula of acetylene, it reacts with oxygen of air and will form carbon dioxide gas and water. This is not hydrogen, okay? This is water. So, because this is called combustion reaction, hydrocarbon may react with oxygen if they form carbon dioxide and water. Now, which substance loses oxygen, loses hydrogen? You can see acetylene, carbon has hydrogen, but in product it loses hydrogen and it gains oxygen. Which substance loses hydrogen? Carbon of acetylene loses hydrogen. So carbon loses hydrogen and gain oxygen. So carbon get oxidized, and oxygen gain that hydrogen atom. So oxygen get reduced. Which substance loses hydrogen? Yes, carbon of acetylene. Which substance gains hydrogen? Oxygen. Oxygen gains hydrogen. Okay. Third example, coal. Coal is burned in thermal power station. This is the thermal power station of coal. And here coal is burned and it produces energy, and that energy is utilized for the production of electric current. You can see the electric poles here. It means the energy is converted into electrical energy. So this coal is burned in thermal power station to produce electricity. When it burns, the following reaction takes place. Carbon burns in the presence of oxygen, which is present in air, and will form carbon dioxide gas. So carbon, you can see that carbon gain oxygen atoms. So gain of oxygen is called oxidation. So carbon is oxidized. Okay, carbon is oxidized and form carbon dioxide. Fourth example is rusting of iron. Rusting of iron, when iron get rusted, when iron react with oxygen which is present in air or water vapor, it forms ferric oxide with some water molecule. This ferric oxide with water molecule is called rust. Rust, and the process is called rusting of iron. You can see as iron gain oxygen atom, and gain of oxygen is called oxidation. So iron get oxidizes by gaining oxygen atom, and this process is called rusting. You can see the iron which has rust on it. Iron reacts with oxygen and will form iron oxide or ferric oxide with some water molecule, and this is called rust. We have an example 7.1. Identify the elements undergoing oxidation. Following reaction occurs when you burn sweet gas. Methane. Methane is present in natural gas. It is also called sweet gas. It is called sweet gas because it is present in Pakistan and Sui, which is a city or an area of Balochistan. So methane or sweet gas or natural gas, methane is present in sweet gas abundantly. It when you burn sweet gas at home, this sweet gas or methane reacts with oxygen and form carbon dioxide, water, and a large amount of heat. Therefore, this is again combustion reaction because burning of hydrocarbon in the presence of oxygen to form carbon dioxide, water, and heat is released is called combustion reaction. Okay. So you can see carbon has 4 hydrogen atoms, but at product side, no hydrogen. It means carbon loses hydrogen atom, and loss of hydrogen is called oxidation. Carbon get oxidized by losing hydrogen atoms and gaining oxygen atom. And oxygen get reduced by gaining hydrogen atoms. Okay, so oxygen is reduced and carbon of methane is oxidized. So they ask identify the element undergoing oxidation. So that element is carbon. Okay, carbon of methane get oxidized by losing hydrogen atom and by gaining oxygen atom. So since carbon in methane loses hydrogen atom and combined with oxygen atom, so this carbon atom undergo oxidation. At the same time, oxygen atom combine with hydrogen atom and form water. Thus, oxygen atoms undergo reduction. Okay. Self-assessment exercise 7.1. Number 1, nitrogen react with hydrogen and form ammonia. So nitrogen gain hydrogen atom and form ammonia, and gain of hydrogen is called reduction. So you can say nitrogen get reduced by gaining hydrogen atom to form ammonia. In second case, hydrogen gain oxygen and gain of oxygen is called oxidation. So hydrogen get oxidized by gaining oxygen atom and form water. The third case is that we discussed before, ferric oxide at the blast furnace. Ferric oxide when react with carbon monoxide. So you can see iron in ferric oxide loses oxygen atom, and loss of oxygen is called reduction. So iron gets reduced by losing oxygen atom, and carbon of carbon monoxide get oxidized by gaining oxygen atom. Okay. Fourth case, you can see aluminium when react with oxygen will form aluminium oxide. So aluminium gain oxygen atom, and gain of oxygen is called oxidation. So aluminium after gaining oxygen atom get oxidized. Got it? So I'm sure you understand this lecture. Inshallah, the second way of oxidation and reduction reaction, that is oxidation and reduction reaction in terms of gain or loss of electrons. Inshallah, we will study in next lecture. Until then, love.